We're going to be looking at the use of a finite geometric series in the application format. So we're looking at Isabel, and Isabel wants to borrow $24,000 for 6 years with an annual interest of 4.5%. So she wants to borrow $24,000. Oh, I don't know, I was thinking 24K instead of putting the dollar sign. I put a K instead. For 6 years at an annual interest rate of ANNUAL interest EREST rate at 4.5% to purchase a food truck business. Those are big, and she really wants to get in with that food truck business. She then needs to make sure that when she's borrowing this, she can actually afford it. What would be her costs just to purchase this food truck? So she needs to make sure every month she could afford it. So the first thing is we're dealing with an annual interest rate. So I need to figure out what my interest rate is compounded. So we're going to be compounding my interest rates monthly. So for my interest rate is going to equal my rate divided by the number of times I'm compounding. And in this case, my rate is 4.5%, and we're going to be compounding that over 12 months. And so I get an interest rate at 0.00375. Well, Isabel went online and she found a formula that will give her her monthly payments, and she knows now what her interest rate per month is going to be. So what she found online was the amount that she's going to pay A is equal to the principal amount she is borrowing divided by the series of K equals 1. So the summation of K equals 1 to N of the function 1 divided by 1 plus I to the K. So we already have all our parts here. The N in this case, though, the N is a little bit different because we're looking at 6 years, but she's looking at a monthly payment. So we need to figure out the 6 years in months. So that's going to be 6 times 12, which in our case is going to be 72. So this is going to equal our N because, again, we're looking at months. Well, knowing this formula, this is right here is my series. This guy right here is my series. And so now what we're going to do is, with this series, I need to know what A1 is. So in my series, A1 is going to equal 1. And this is a K. This is not a K minus 1, which we have seen in our last series. So I'm just going to put 1 in for K, because that would be our first month. This is our first month, term value 1. 1 plus 0.00375, 0.003 would be 1.00375 to the first value, which is going to be approximately 0.996. All right. My rate in this case happens to be the same thing. So my rate is going to be the 1 over 1.00375. This is my rate, no exponent, because this is x to the power 1. This is just my rate. And this too is approximately 0.996. So you're probably thinking, Miss Abney, why did we bring all this out? Why are we doing all of this? Well, we're doing, we could plug this into the calculator. We could plug our summations into the calculator and get our answer. But what we really want to do is we just basically want to find the sum. So in this case, this summation, again, we could use the calculator for this, but in this case, we are going to be looking at the summation equation. So if you remember that from past examples, S of n is going to equal A1 times 1 minus r to the n power divided by 1 minus r. And using substitution, I don't know why I put the, because we have approximate here, 0.996 times 1 minus 0.996 to the 72nd value, all divided by 1 minus 0.996. I'm getting a lot of numbers in here. So let me just finish this off by the approximation of 62.417. Okay, so that gave us this bottom piece. We figured out this bottom piece through all this work. So now what we need to do is we need to take that bottom piece, 24,123, divided by 62.417, what we just found by using the summation equation. And now what we get, oh, this is an approximate because this is an approximate, 62 is the approximate. We get approximately 384.51. So all that work, if we can remember back to what we were finding what A was that monthly payment that she would have to pay for the loan. So Isabel's monthly payment for the loan would be $384.51. And again, a lot of you know or have heard in the videos that you can actually do summations on a TI-80 for calculator. You could do it on 83 too, 83 as well, not an 83 too. There is a summation key. You can actually, there's a great YouTube videos on that. I do not have the calculator on the computer that I'm presenting on now, but I can show you if you would like to know in a classroom setting during one of our in live person classes on Google Meets. Just let me know, and I can show you how to do this on the calculator for that summation. It does take a while. It does use a lot of the memory of the calculator because you're summing 72 terms, which makes that S of n equation a little bit better. All right, guys, so that is using a finite geometric series for word problems. So if you have any questions, anything that you want me to go over in more detail, please let me know, and I will catch you in the next video.